how do giants navigate through fog without hitting anything invisible? But the real mystery lies in how they track ghosts. Think of radar like a bat shouting into the dark. Tiny electrical pulses return as a map of the ocean. Every ship broadcasts its name, speed, and exact global position. Combining radar and GPS data creates a perfect digital twin. Even with tech, a captain's eyes are the final judge. Stopping these titans takes miles, so precision is actually survival. Computers calculate collision risks faster than any human ever could. Ready to see how they dock these giants without crashing? Thick fog turns the open ocean into a blind trap. Radar acts like a digital eye piercing through the white. It sends out radio pulses that bounce off nearby objects. Every tiny blip on the screen represents a potential disaster. Advanced computers track these targets to predict their exact path. AIS transponders broadcast the ship's identity, speed, and heading constantly. Think of it like a GPS that tells you everything. Complex antennas are the secret backbone of this entire system. Even with tech, eyes and ears remain the final check. But what if the digital connection suddenly goes completely dark? Thick fog turns the massive ocean into a blind trap. Radar pulses bounce off distant objects to map the surroundings. It measures how long echoes take to return to sensors. These rotating scanners are the ship's most vital sensory organ. Computers filter out rain noise to find real solid targets. Automatic identification systems let ships share their exact GPS location. Software calculates if two ships will occupy the same space. Think of it like a GPS map for your car. These systems run constantly to keep the giant hulls safe. But what happens when the digital systems suddenly go dark? A wall of gray fog hides thousands of tons ahead. Radar pulses bounce off objects to map the hidden horizon. It paints a glowing digital map of every nearby vessel. Think of it like throwing a ball against a wall. The time the echo takes tells us the exact distance. Ships also broadcast their names and speed to every neighbor. Computers calculate collision risks before a captain even notices them. It is like tracking a mosquito while driving a tank. Yet, these machines only assist the crew's final critical decisions. Imagine driving a skyscraper through a thick, white, wet blanket. The ship fires radio pulses that bounce off distant objects. The computer times these echoes to calculate the exact distance. This rotating antenna acts like a sweeping lighthouse of data. We use two bands, one for range, one for detail. Small wooden boats can sometimes hide in the radar shadows. Ships also broadcast their identity, speed, and exact global position. It is like having a glowing map of the invisible. But what happens when the digital map suddenly goes dark? Radar pulses bounce off objects to reveal hidden ghost shapes. Computers filter out rain clutter to find real solid targets. Every ship broadcasts its precise location using automated satellite signals. Software overlays radar blobs with real-time digital ship identity tags. Algorithms calculate if two ships will occupy the same space. Hit the subscribe button and press the bell icon to get updates. Captain's eyes confirm what the digital screen is telling them. It is a layered shield of sensors protecting every vessel. Wait until you see how they handle engine failure mid-ocean. Radio waves bounce off steel hulls to reveal hidden obstacles. The computer converts those echoes into a clear digital map. Captains overlay these radar dots onto precise electronic nautical charts. Every ship broadcasts its name, speed, and position to others. This data creates a live stream of every nearby vessel. Alarms trigger if two ships calculate a dangerous future path. Officers interpret these signals to make split-second steering decisions. It is like having a superpower that ignores the weather. Technology keeps these giants moving safely through the thickest fog. Radar pulses bounce off metal, painting a map of ghosts. Rotating antennas sweep the horizon, catching every tiny metal echo. AIS broadcasts exact locations, turning ships into glowing digital dots. Captains blend screen data with experience to predict sudden movements. Loud horn blasts cut through silence, warning others of presence. They crawl at half speed, giving time to react safely. It is not just tech, it is a human-machine partnership. These complex systems ensure your goods arrive, regardless of weather. The evidence points to a much deeper story.